analytics dataset project. And the main objective of this project is to capture the important KPIs that would be helpful for any stable operator, and also extracting the extended data for stable KPIs. So the core goals of the projects were to write SQL scripts and core scripts to answer important questions related to stable data sets, some Python scripts to extract and integrate extended metadata into the process. There were some scripts written to load this extended metadata into S3 buckets, and then finally some Python scripts to extract and load stable and aggregate data into S3. So aggregate data here means the aggregations of KPIs at epoch, month, and year level. The non-goals of this project are basically setting up any DB-sync database, any insights into transactional data sets, and any kind of scheduling or hosted data service for now. So for the prerequisite of this project, you need to have an up and running host database instance that hosts DB-sync. You need to set up some environment variables. So the environment variables would basically be the DB host, DB name, username, password for the DB-sync. And if you intend to export this data into S3, you need to have your AWS Access Key ID and AWS Access Secret Key. We have used PyEnv here, which uses Python 3.8 and 9. Feel free to use another Python versions. You might have to install dependencies. So for dependency management, we have used Poetry here. There are basic formatting or linting that have been followed for different parts of the project. So for the developer setup, any stateful operator, here our assumption is the developers here will be stateful operators who are interested in providing insights about their stateful. So you need to have your DB-sync set up in first place. There's already a guide to set up your DB-sync on the Cardano community GitHub. So here you can find all the step-by-step documentation for setting up DB-sync. Once you have DB-sync set up, you can clone the project using the following GitHub repository. Once you have the GitHub code, you can use any SQL Explorer of your choice, Navicat, DB Visualizer, BG Benjamin, and anything like that. And you need to install or you need to run base views, which could be found in the resources intermediate part. So going over the resources, we have all the SQL scripts that are here. So we have core scripts, which talk about all the matrices. We have DDL scripts, which will create the basic schema for all the aggregation data sets. And we have the intermediate where I was talking about base views. And basically, the base views are some pre-written SQL scripts that simplifies the extraction of these KPIs and other metrics. So once all of that is done, the developers are ready to dive in and start running some extraction commands. So again, we use for extracting stateful metadata, you can use for Poetry run Python stateful operations and just metadata.py. Stateful metadata here consists of information like JSON extracts from extended metadata, structured CSV data for stateful socials, so things like Telegram, Twitter IDs, YouTube channel IDs, and other social media IDs like for example, Instagram links, Discord links, and so on and so forth. And then there's another structured CSV data set which has information about stateful ITN and owner information. So before exporting stateful metadata to S3, the data first needs to be ingested and integrated in Postgres. This can be accomplished using the command mentioned here. Once this data set is in Postgres, you can either export it to S3 using the following command, or just use Postgres to get insights from the extended metadata. Another aspect of this project is the stateful KPIs, and I would like to spend some more time here discussing what these KPIs are. So a KPI is key performance indicator, and especially with respect to stake pools, these can be defined in terms of attrition, growth, performance. So basically, attrition is total number of pools that were retired during an epoch or a month or a year. Important thing for this project is the most granular data that we have collected is at an epoch level. And then we have data for month and year based on epochs. So attrition would basically mean change of pools or the count of pools that retire during an epoch, month, and year. Similarly, we have growth KPI, which would mean newly added pools during an epoch, month, and year. Performance. So performance, we have two kind of indicators. One is amount of data delegated, and second is the number of wallet delegated. So, and both we basically give a count of these indicators and the change, or you would say the delta. And this could be useful for the stateful operators because there could be data dedicators which would have huge sums of Cardano delegated to a stateful. So there could be just 5 delegations, but each one of them might contribute 10,000 Cardano. Whereas there could be a scenario where there are thousands of wallet delegators, but each of them having 100 Cardano delegated. So this can provide significant insights in terms of performance for those stateful operations. Another set of KPIs or data points that are not defined in terms of a longer interval and only available by epoch are pledge versus return on asset. So it defines basically what is the pool performance in terms of its pledge. Again, this is only available by epoch. And then there are KPIs or data points that talk about the effects of changing pool parameters. So it's basically a data set that defines the changes a stateful operator has performed on a pool, and then what was the performance of those changes. And there's a different module to extract the KPI, which is called as the ETL KPIs. And basically, you need to provide a KPI name and the interval for that KPI. So the interval could be epoch, month, or year. So the following KPI are available in this release: attrition rate, growth rate, performance, pledge, pool parameters. To type into the code, we have basically the lib, which are nothing but the helper functions. One of them is basically to get a Bodo 3 resource, which helps us connect to any AWS service. And another one is the dbcon helper, which basically helps us to create a stub that will be used to connect to the dbsync Postgres database. Moving on, we have stateful operations, which is the main ingredient for this project. So we have things like ETL KPIs, which basically help us to extract these KPIs, and these are a set of Python functions that will be used to extract data. Moving on, we have extract and load py, which basically is the same thing, but it does the operations on a higher level. And then we have the scripts for extracting pool metadata. And basically, it queries the Postgres database and then run a certain number of threads to get all of the extended pool metadata for defined number of pools or all of the pools. And basically, the pool means there would be a pool ID for each stake pool. And then we have stake pool analytics. Oh, so stateful analytics was uh, was renamed to extract pool metadata. And this project has been tested using PyTests. So we have two testing scripts, each testing the lib and extract pool metadata datasets. So far everything has been defined in the code documentation. And yeah, that's the first release. And as things move forward and if there are more opportunities, we will be creating this time progress. I'm done here.